Welcome to the crash site. This is the segfault ledger. The internet is fragile, but long before the web existed, humanity built a different kind of global network. A few months back, I was out in Washington State, taking a break from the outdoors to look for some computing history. I ended up at a telecommunications museum in Seattle. I walked in expecting to look at some vintage hardware, maybe some old copper infrastructure and switchboards. But what I actually found was the origin story of the modern hacker. In the 1960s and 70s, AT&T owned the largest, most expensive machine ever built, the global telephone network. It was a masterpiece of mechanical engineering. These facilities were essentially the world's first massive hardware routers, physically connecting lines across continents. It was supposed to be completely impenetrable. But the engineers made one catastrophic, fundamental architecture flaw. Because of that single oversight, a blind teenager with perfect pitch, a Vietnam veteran, and a plastic whistle hidden inside a box of Cap'n Crunch cereal were able to completely hijack the global communications grid. This isn't just the story of people stealing free long-distance calls. This is the birth of cybersecurity, and the first time anyone realized that if you understand the rules of a system better than the people who built it, you can take control. To understand how a toy whistle could break a multi-billion-dollar network, you have to look at the routing logic. When you made a long-distance call back then, your voice didn't just travel down one direct wire. It passed through a hierarchy of massive mechanical switches. To tell a switch further down the line to open up a trunk line and connect your call, the system used audio tones. Specifically, a high-pitched tone ringing at exactly 2600 hertz. Here was the fatal flaw. The system used something called in-band signaling. In modern network infrastructure, we generally separate the control plane from the data plane. The commands telling the network hardware what to do are kept strictly isolated from the actual user payload. But AT&T didn't do that. They pushed the routing commands over the exact same audio channel as the user's voice. Imagine if an internet router couldn't tell the difference between the packet header containing the destination IP and the actual text inside the packet. That was AT&T's network. The hardware couldn't tell if that 2600 hertz tone was being generated by an official AT&T operator console or if it was just a sound coming out of the mouthpiece of a payphone. The first person to really exploit this vulnerability didn't even use a computer. His name was Joseph Ingrescia, a blind teenager who later went by the name Joy Bubbles. Joseph had perfect pitch. He realized he could literally just whistle into a telephone receiver at exactly 2600 hertz. When he did, the switch would think the call was over and stop billing him, but it didn't hang up the physical line. It dropped him into an operator mode. From there, he could dial himself anywhere in the world, completely free. But not everyone has perfect pitch. Enter John Draper. Draper was a former Air Force radar technician with a deep understanding of electronics. He discovered that a cheap plastic toy whistle, currently being given away as a prize in boxes of Cap'n Crunch cereal, happened to produce exactly a 2600 hertz tone. You blow the whistle into the phone, the trunk line opens, and you own the network. Draper became a legend, earning the nickname Captain Crunch. This exploit gave rise to an entire underground subculture known as Phreaking. These weren't just kids looking to save a few bucks. They were early rogue network engineers. They would chain calls across dozens of international routing trunks, bouncing a signal from New York to London to Tokyo, just to make the payphone right next to them ring. They were mapping the topology of a closed system, probing its edges just to see how it worked. The whistle was a blunt instrument and a bit tedious to use. As the Phreaking community grew, they started building custom hardware. They designed devices called blue boxes. These were custom-built electronic tone generators wired up with oscillators that could perfectly replicate every internal routing frequency AT&T used. It was pure hardware engineering, circuit boards soldered together in basements that could override the most complex infrastructure on Earth. And this is where computing history takes a massive turn. In the fall of 1971, two college kids in California read an article about phreaking. They were so obsessed with the mechanics of the exploit that they tracked down John Draper, learned the system, and started building their own blue boxes to sell out of their dorm rooms. Those two kids were Steve Wozniak and Steve Jobs. They built their first business partnership not on commercial computers, but on hacking the telecom network. Years later, Steve Jobs famously admitted that without the blue box, there never would have been an Apple. Eventually, the latency between the vulnerability and the consequence caught up. AT&T noticed the massive irregularities in their routing tables. The FBI got involved, and several prominent phreakers, including John Draper, served prison time. But you can't arrest an architecture flaw. AT&T had to fundamentally redesign their infrastructure. They finally moved to out-of-band signaling, creating an entirely separate, isolated network just for the routing commands, a standard known as Signaling System 7. The switches stopped listening to the user's voice channel for instructions. The control plane was secured, and the era of the blue box was abruptly over. But the foundation for the digital world was laid. The Phreakers proved that no matter how massive or intimidating a system is, it is only as secure as its lowest level logic. This has been the SegFault Ledger. If you want to trace the execution paths of more digital disasters, catastrophic software bugs, and the forgotten architecture of the internet, hit subscribe. Let me know in the comments what system failure we should look at next. Until then, mind your code.